All right, guys, here we go. We're going to do this review in two halves. So let's just get started here. You are going to need a calculator. So if you're not doing this in class, then you can do it at home. Just make sure in your calculator when you push the mode button that degree is highlighted. Okay, if degree is not highlighted, then all of these questions are not going to come out right. Okay. So let's take a look at triangle number one. So we have an angle and a side that are opposite each other. So remember, whenever you already know an angle and a side that are opposite each other, you're going to do law of sines. So let's review how to label the triangle. So capital A is for this angle, goes across from side A. Angle B goes across from side B. And then angle C goes across from side C. So given that we know the angle for C and the side for C, we're going to set up our law of sines. So I'll do the sine of 61 over the side across from it, 5.2. And then I'll set it up equal to the sine of B, which I don't know, over side B, which is 4.5. And then remember from there, you just need to cross multiply. So in the calculator, I'm going to do 5.2 times sine B equal to, and then I'm going to multiply this in the calculator here. So it's the sine of 61 times 4.5. So I got 3.935. We'll just go 3.9. Then I'm going to divide the 5.2 across. So that now I have the sine of B is 3.9 over 5.2. And then remember to cancel out the sign, we're going to do inverse sine, which is like the little sign to the -1. And remember on your calculator, that's second sine. So you can watch me push the buttons here. It's second sine, 3.9 over 5.2. So I got 48 degrees. That's the measure of angle B. Okay. So, and actually let's round that. If it's 48.5, let's round that up to 49 degrees. Okay, so then you'll notice we have measure B, it was 49 degrees. Well, then now they want us to find the measure of angle A. Remember that all three of these angles add up to 180. So to find the measure of angle A, I'm going to do 180 minus the 61 degrees that I had already, minus the 49 degrees that I just found, and then whatever's left over, that's going to be angle A. So they all add to 180 minus the 61 minus the 49. I know my remaining angle is 70 degrees. And then we have one more side left to find. We need to find side A. So to do that, I'm going to set up another law of sines because now I know the angle and I just need the side to go with it. So I'm going to try to write a little bit smaller, but I'm going to fit it in right here. So this side stays the same. Sine 61 over 5.2 equals. But now I know the angle is 70. And what I don't know is how long side A is. And then I'm going to cross multiply. So I have A times sine 61 equals, and then I'm going to multiply this side out. So it's 5.2 times the sine of 70. I got 4.88. I'm going to round that to 4.9. And then my next step would be to divide this side of 61 out of the way. So whatever 4.9 is divided by sine 61, that's going to be my answer. And I got 5.6. Okay, and then remember your triangle is fully solved once you know all three angles. So I know these three angles and I know the three sides that go with it. Okay, so your triangle is fully solved when you know all the angles and all the sides. Okay, take a look at number 3. It says find the length of side C given that A is 8, measure of angle A is 62, measure of angle C is 34. So remember that if this is your angle A here at the bottom, which is 62, then it goes across from side A, which it says is 8. And then I know that measure of angle C is 34, that would go here. But I want to find the length of side C, so that would be here. And remember, it's always capital letters and little letters across the triangle from each other. Well, then I know angle A, I know side A, then I can do law of sines. So I'll start with that. Sine 62 over side 8 equals the sine of 34 over side C. And then from there, you're just going to cross multiply. So I'll do sine of 62 times C. And then on the other side, I'll multiply it out 8 times the sine of 34. So I got 4.47. We'll round that to 4.5. And then last step would be to divide this side of 62 out of the way. So then I have C equals 4.5 divided by sine 62. I get 5.09, so I'm going to round that to 5.1. Okay. All right. Now, you'll notice that on number 2, actually, we'll do this one on number 4. Okay. So go ahead and number 2, you're going to need to use law of sines or cosines, which is right here. Okay, but we're going to do that on the next example. So just know that for this example 2, you are going to have to use the law of cosines. Okay, but we're going to work number 4. So remember, we're not going to work every single question in these helper videos. We're just going to work some of them. Okay, so here's what it says. Magnitude of 2 vectors, A is 4, B is 13. When they're placed tail to tail, the angle between them is 105. Find the length of the resultant vector. Okay, so we'll say A is here. And it tells us that it's 4. And then it tells us that B is 13. So we'll say this is B is 13. And then it says that the angle between them, right here it says this, is 105. And then it asks you to find the resultant vector. Well, the resultant vector is basically just the third side of the triangle. So that's the side that we're trying to find. Okay. So let's just label our corners. If this is little a, then we'll call this A. Then we'll call this big A. We'll call this little c. We'll call this capital C. And then we'll call this big B, which would make this little b. Okay. So the reason we're going to have to do law of cosines on this is because we don't know a capital and a lowercase of the same letter, meaning we don't know an angle and a side for the same letter. So for example, for A, I know the side, but I don't know the angle. B, I know the side, but I don't know the angle. And then C, I know the angle, but I don't know the side. So this is going to be law of cosines. Okay, law of cosines is this. C squared equals A squared plus B squared minus 2AB cosine C. And if you flip back over to the page we were just on, you'll see law of cosines is right up here at the top. Okay, all we have to do is fill in the blanks. So it's C squared equals A squared is 4 squared plus 13 squared for my B minus 2AB is 4 times 13. and then times the cosine of C, which is 105. And then all that I'm going to do is type this whole thing in at once. So 4 squared plus 13 squared minus 2 times 4 times 13 times the cosine of 5. I get C squared equals 211.9. And then notice that's C squared, not C. So I'll have to go back and take the square root. And I got 14.6. Okay, so remember, law of cosines is when you don't have a letter that you know the angle and the sine. Okay. All right, let's do number 5. So it says, we know that the sine of theta is -4/7, and we know it lies in quadrant 4. So let's just review real quick. Okay, it's 1, 2, 3, 4. And then it tells me that the sine is -4/7. Well, remember, your triangle should always connect back to the x-axis. And then remember that wherever your theta is, the side opposite your theta is going to be the y. The adjacent is always the x. And then remember that this side in the middle, that's your hypotenuse. Okay. And so then if they tell you that the sine of theta is -4/7, it says that right here. If the sine of theta is -4/7, well, then if you remember, that's so, and then remember it goes ka and then toa. So that means that this is the opposite and this is the hypotenuse. Okay, because remember, it's so ka toa, but then they're telling you the sine is -4/7. Well, then my opposite is -4, and my hypotenuse is the 7. Okay, so let's go back and look at part A. It says find the missing side. Well, remember, if I know these two sides, I can find this side using Pythagorean theorem. So I'm going to do a squared plus 4 squared equals 7 squared. That's a squared plus 16. And then 7 squared is 49. Minus that 16 across. And I have a squared equals, that'd be 33. And then take the square root. So this side here is the square root of 33. And then remember from there, for the SOHCAHTOA, all I have to do is follow the order of the fractions. So sine, I already knew it was -4/7. For ka, it's adjacent over hypotenuse, so it's √33/7. And then tan is opposite over adjacent, so it'd be -4/√33. Okay, then remember that these three functions are called the reciprocal IDs. That means that they're the original three functions, but flipped. So if sine's -4/7, cosecant is -7/4. √33 is now on the bottom, and it's 7/√33. And then tan is going to flip to be √33/4. Remember the negative, you can put it in the bottom, but I just kind of put it usually in the front. Okay. Then out of each of those questions, you can see that most of them are good. The only time that an answer would not be good would be if you had a square root that was written on the bottom. So I can see that these two I'm going to have to fix by repeating the square root. So I'll do another √33 here and here. That gives me 7√33/33. And then I'll do the same thing on this one. So remember, if your square root's at the bottom, you're going to have to fix that by repeating the roots. So then I have -4√33 over regular 33. Okay. And now that one's done. Notice that on number 6, you don't have to find all 6 of the functions. You only have to find secant. So if cosine is a over h, then secant is going to be h over a. So I'll put a little note here. Secant is h over a. So you'll still have to set up your graph, find the missing side, but then instead of having to do all 6, you're only finding secant. Okay, go ahead and turn the page when you're ready. Okay, next one, we have a window 20 meters high has an angle of depression to the top of the street light at 50 degrees. The angle of depression to the base of the street light is 58 degrees. How tall is the street light? So let's go ahead and set up a little picture here. You have a window. Okay, it says it's 20 meters off the ground. And then it says there's an angle of depression to a street light. We'll draw the street light over here. Yeah, that's kind of ugly, but just pretend. Okay, there's the street light. And it says the angle of depression to the street light is 50 degrees. So all that an angle of depression is if you were looking straight from the window and then you measure down, that's an angle of depression. Okay. And it tells us it's 50 degrees. Now, I will say that if you're one of the unlucky people that has to take the final, they did draw this picture for you. But I just wanted you to have a little bit of practice with it in drawing it yourself. So we have the angle of depression is 50 degrees. Then it says the angle of depression from the base of the street light is 58 degrees. And that should be from the base of the street light. This like the street light. Oh, okay, got it. So then it says the angle of depression to the top of the light is 50. And then it says the angle of depression to the base of the light is 58. So I want you to think about here to here is 50. Here to here is 58. Okay, that's what they just gave you. And then they're asking you, how tall is the street light? So we notice that we have 2 triangles. Hopefully you notice that. You have the orange triangle that goes all the way to the ground. And then you have the green triangle that goes only to the top of the street light. And so then if they're asking me how tall the street light is, then I mainly just care about that. Yeah. So that's going to be my final answer, but we're going to have to find it. So let's start off with, we know that these are SOHCAHTOA problems. So we know that this is 50 degrees. And we know how tall this full long side is here because it tells me the window's 20 degrees in the air. So if I were to, let's start with the orange triangle. The sine of 58 equals opposite over hypotenuse. So my opposite side is here, which is 20. And then my hypotenuse, I do not know. So we'll do 20 over, let's call it h for hypotenuse. So sine is opposite over hypotenuse. We're going to cross multiply. So put your sine of 58 over 1, h times sine 58 is equal to 20 times 1, and then divide the sine of 58. So we have 20 divided by the sine of 58. That gives me 23.5. We'll round that to 23.6. So my total h for the hypotenuse is 23.6. And that's this distance here. Okay. Then let's also find this distance here as well. So instead of using sine, I'm going to use cosine, and here's why. For cosine of 58, instead of doing O over H, I'm going to do A over H. My A, I don't know, but my H I know now is 23.6. And then from there, we can cross multiply. Also notice that we're using the sine of 58 because we're doing this big giant triangle, not the little green one. Okay. So from there, let's cross multiply. So we'll do 23.6 times the sine of 58 equal to 1 times A is just A. And then the cosine of 58 times 23.6, that gives me 12. So now let's label that here. This is 12.5. Okay, and you might be wondering, okay, well, how does this help? Okay, let's think about it. We now know all three of these sides, 23.6, 12.5, and then this full side, top to bottom, is 20. Well, then if I can know how long this side is, the full side is 20, then if I subtract these two, I'll know my answer for the line. So for our last triangle now, we're going to use the little orange one. So here's my 50 degrees. I want this side, but I know this side. So pretend this orange triangle isn't here. Here's the 50 degrees. Well, then this is the opposite. This is the hypotenuse. And this is the adjacent. I don't know the green hypotenuse. I knew the hypotenuse for orange, but I don't know it for green. Well, then I'm going to use tan. Here's why. Remember that tan is opposite over adjacent. So I know tan of 50 is opposite, which is what I'm looking for, over the adjacent, which I know is 12.5. So we'll do opposite over 12.5. And then from there, we're just cross multiply and put that over. Okay, but again, why did I pick tan? Because I want to know this side. I already know this side. Okay, so it's going to be 1 times opposite is opposite. And then tan of 50 times 12.5, that gives me 5. That gives me 14.89, which we're going to round to 14.9. Okay, so now let's think about the whole distance from here to the ground is 20. And I only care about how tall the street light is. Well, then think about it. If this is 14.9, but then all the way to the ground it's 20, then my final answer is just going to be to subtract these two. That'll tell me how tall the street light is. So I'm going to do 20 minus 14.9, and that tells me the street light is 5.1 feet tall. Or meters tall. Okay. So then this would be 5.1. Okay. That one was a little bit more involved, but hopefully you can kind of understand how we use tricks to solve that. Okay, next little bit of this, we're going to do some vectors. Remember, vectors in terms of I and J are super easy. You just put I with the first letter, and then J with the second. So it'd be -2I minus 4J. Right, vector C in component form, we'll take a look at it right here. Right now, it's in terms of I and J. We want to go back to component vector form. That just means you're going to put the little pointy brackets and then take the I and the J out. So your -2 first, your -7 second. Okay, this is in terms of I and J. This is component vector form. Okay, hopefully we see the difference there. Okay, then it asks you to add and subtract the vectors. So remember, you can do this algebraically or you can do it graphically. They're asking us to do it graphically. So what we're going to do is I'm going to start at the origin. Vector B is 5, 6. So that would be 5 up 6 here. That's vector B. And then it says to add vector A. So let's review how to add vectors. You basically just attach the second one to the end of the first one. So if it's -2, -4, I'm going to start here and go back to 1, 2, 3, 4. My second vector is going to be there. So remember, you're always adding them head to tail where you draw the first vector and then you start the second one right at the end of the first one. Okay. And then your answer vector or your resultant vector would be this guy right here. Okay, and if I were to count out that orange vector, I can see that it looks like it's a distance of 1, 2, 3 up 1. Okay, now let me show you a little trick. Okay, if you had actually just added these numbers up, hopefully you remember you just add the x's, add the y's. What's 5 plus -2? 3. And then what's 6 minus 4? Ooh, this should be 2. Okay, which means I didn't quite draw my vector long enough. It should be, redraw it. So we went here to here. Oh yeah, see how my arrow ends there? So I should have drawn it all the way back to there. So now it's 1, 2, 3, up 2. And so 3, 2 would be your answer. So if you remember how to do it algebraically, you can check your work and just make sure you don't make mistakes. Okay, last one we're going to do on this page is letter F, A minus C. So I'm going to start with A. A is -2, -4. And then I want to minus C. And C was -2, -7. Okay. Well, remember that when you subtract a vector, you just need to take that negative and put it into the vector. So for example, I'm going to start at the origin here. -2, -4 would be back 2, down 1. This fly is attacking. Okay. So -2, -1, 2, 3, 4 is here. And then for my second vector, it was -2, -7. But if this negative is here, I'm going to push that in. Now I see that this -2 is going to be a +2. And my -7 is a +7. So then I'm going to start here and I'm going to go over 2 and then up 1, 2, 3, 4, 5, 6, 7. And then remember that your resultant vector, you connect the original starting point to the new end point. So it's going to be from here to here. That would be your answer vector. And then remember, you can just count your x first. So since it goes straight up, my x is a 0 and my y is a 1, 2, 3. Okay, then let's check our work. What is -2 plus 2? Oh, it's 0. Great. And then what is -4 added to 7? 3. And so that we can see that we did it right. Okay. All right, go ahead and turn the page when you're ready. We'll just do one of these. Let's say we want to do letter H. We want 2a minus 3c. Okay, well then 2 times a is 2 times -2, -4. Minus 3 times c is -2, -7. Okay, remember order of operations on this. You're going to times the numbers on the outside in, and then you're going to add the x's and then add the y's. So 2 times -2, that's a -4. 2 times -4, now that's a -8. -3 times -2, careful on your signs here, that's a +6. -3 times -7, that's a +21. And then notice that once I push that negative in, now it's just a regular plus in the middle. And then from there, remember, you're adding the x's together, you're adding the y's together. So -4 and 6, that gives you 2. And then -8 and 21, that's going to give you 13. Oh my gosh, this and then there's your answer. Okay. All right, go ahead and take a look at the next one. Okay, it says to draw the vector, find the magnitude, and then find the direction. So remember, when you're drawing these vectors, pictures don't have to be perfect, you're just sketching it. So for example, if it's -5, 12, I would go to the left 5 and then up 12, my vector would be here. Okay, so remember, it's -5, up 12, then my vector is here. Okay, it says to find the magnitude, you will have a formula chart. Remember, magnitude is a squared plus b squared, and then take the square root. So I would do 5 squared plus 12 squared, and then take the square root. So in the calculator, we have 5 squared plus 12 squared, and then take the square root of that answer. So I got 13. Remember specifically what the magnitude is how long it is. So I know that 13, that's the length of that vector. Okay. All right, then go to part B. It says to find the direction of the vector. Remember, direction is tan theta equals y over x. Okay, in this case, my y is a 12, my x is a -5. So I would do tan theta equals 12 over -5. Okay, and then remember, actually, you don't really need the negative for the tans. Just type it in without. To cancel out the tan, we're going to do inverse tan. So then in my calculator here, I'm going to do second tan 12 over 5. And I got 67 degrees. Okay, from there, remember, this is not your final answer. That is called your reference angle. Okay, the last thing that you have to do after finding the reference angle is consider what quadrant you're in. So I'll give you the formulas for each of the quadrants. If you're in quadrant 1, theta is your answer. If you're in quadrant 2, it's 180 minus the theta. Quadrant 3 is 180 plus the theta. And then quadrant 4 is 360 minus theta. So I can see that I was in quadrant 2. Well, then I'm going to do 180 minus 67. That's going to be my final. So for my direction, I see I'm in quadrant 2, which means I'm going to do 180 minus 67, and that'll be my answer. 180 minus 67 gives me 113. Okay, and remember the reason for that, in case you care, is that direction is always measured starting here and then rotating this way. Starting here and then rotating this way. So this side is 67, but the long way, that's the 113. Okay. All right, go on to the next page, please. Okay, y'all, this is the biggest slide I've ever seen. Okay. All right, let's take a look at 11. So it says we know A is 4 in length at 105, B is 13 in length at 45. So for the component vector for A, remember that it's the length cosine theta and then the length sine theta for component form. So if I want to do it for A, for example, I know that it's 4 units long. I know the angle is 105. So it's 4 cosine 105, 4 sine 105. Then it says to do the same for B. So it tells me B is 13 units long. And then the angle is 45 degrees. Well, then it's 13 cosine 45 and then 13 sine 45. Okay, then it says to find the resultant vector. Remember, resultant just means that you're adding, so you're gonna add the x's together, and then you're gonna add the y's together. Remember, you would do this part in your calculator, not by hand. Okay. So I'm gonna type in 4 cosine 105 plus, make sure you close this parentheses here, and then 13 cosine 45. Okay, so I got 8.15, we'll round that to 8.2. Then for my 4 sine 105 plus 13 sine 45, I got 13.05, we'll round that to 13.1. So it's 8.2 and then 13.1. Okay. Then from there, it asks you for the magnitude and the direction. So hopefully if you remember how to do that, it'd be 8.2 squared plus 13.1 squared. Take the square root. So 8.2 squared, 13.1 squared, we got 15.45. And then remember that 4 is going to bump up to be a 15.5. Okay, that would be how long the vector is. Okay, then to do the direction, remember it would be tan theta equals y over x. So 13.1 over my x with an 8.2. And then remember that when you type it in, you're using the inverse tan to know the angle. So it'd be second tan 13.1 over 8.2. Okay, so my angle came out to be 57.9, so I'm going to round that to 58. Okay, now let's think about for a second. My vector was 8.2 and then 13.1. So now let's think about our quadrant, because remember, technically this is the reference angle. We still have to make that little chart. But think about if my 8.2 and my 13 are both positive, then I'd go 8.2 this way, 13.1 this way, and my vector would end up here. Okay, so if these are both positive, I'm ending up in quadrant 1. And remember, in quadrant 1, your theta is your answer. So that means that this is the reference angle and it's the direction, because they're basically the same for that. Okay. All right, last little bit of this in the first half. Let's take a look at your unit circle. So remember that sine and cosine are the x and the y's. So sine is your y value. Cosine is your x value. So for example, if I wanted the sine of 60 degrees, I would find 60 degrees right here. And then I would pick the y value, which is root 3 over 2. Similarly, if I was doing the cosine of 210, I would find 210. So this is 180, 210 is here. Trace that out to the ordered pair, but then I pick the x value, which is negative root 3 over 2 for that one. Okay. Then remember that cosecant and secant are sine and cosine flipped. Cosecant is sine flipped, and secant is cosine flipped. Okay. So let's do 2 of those in, let's do, I'll just do this one. So 150 is here. We're rotating around to this spot. And then I want the sine flipped. Sine is my y value, so it's a half, but then I'm going to flip it is 2 over 1, which is 2. Secant, I'm going to go to 135. 135 is here. I'm going to trace it out to the ordered pair. And then for secant, I'm doing cosine flipped, which is negative root 2 over 2. So that'd be negative 2 over root 2 when I flip it. Remember, you can't leave square roots on the bottom. So to fix that, we're going to put another root 2 here and here. And so then at that point, I have negative 2 root 2 on top. And then root 2 times root 2 again becomes a regular 2. Okay, then hopefully you can recognize that at that point, you're still not really done, because if you have a 2 top and bottom, let's just cross those out. So these are both gone, and your answer would just be negative root 2. Okay. We'll do one tan and one cotan. Let's go down to number 21 though and work a couple of radians. Remember, the way you work it is the same. It's just how you measure the angle. So if I'm doing tan, remember tan is y over x versus cotan is x over y. So if tan is y over x, find 3 pi fourths. 3 pi fourths is here. So I'm actually in that exact same ordered pair that I was looking at before, but I'm going to put y over x. So in that case, it's root 2 over 2 divided by negative root 2 over 2. And then remember, the way you divide fractions is you keep the top one the same and you flip the bottom one. So for example, my root 2 over 2 is going to stay, but then I'm going to have to flip this bottom one. So it'd be negative 2 over root 2. And then watch what happens here. My root 2's, I have one on top, one on bottom. And then negative 2 divided by 2, my final answer is just negative 1. Okay. Very similar for 22. The big difference, like I said, is that if it's tan, it's y over x. Cotan is x over y. So I see that my x here at 11 pi over 6 is way down here. Okay, I see that my x is root 3 over 2 divided by my y is negative 1/2. And then remember, keep the top one the same, root 3 over 2, but then you're going to flip this one. So it'd be 2 over 1. And then I'm like, oh, 2 over 2, those cross out. That just gives me 1. Well, then all I'm left with is a negative. Remember, if your answer ends up having a square root left on the bottom, then you are supposed to fix it if you end up taking your exam. Okay. All right. Go ahead and turn to the next page. We're almost done with first half. Remember, if your angles are too big or too small, okay, all that you have to do is add or subtract 360. So for example, 420, that angle's too big, then I'm gonna minus 360 off of it, okay? So I would do 420 minus 360, take a rotation off, and then I get 60 degrees, well, then I'll just take the cosine of that. And then I look at my circle, find 60 degrees. 60 degrees is here. And then I want the cosine. Cosine's the x value, so I'm picking 1. Okay, take a look at 24. That one's too big as well. Okay, 840, that's not going to show up on my circle. So I'm going to minus 360 degrees off. So 840 minus 360, that gives me 480. And then I look at my circle and I'm like, oh, wait, that's still too big. Okay, so I got 480. Okay, but that's still too big. Then remember, you can just minus 360 off again. So 480 minus 360 again, that gets me. And now I'm within my range on my circle that I can find that. So 120 is here. Okay, 120 is this one. Okay, then remember, cosine's the x, sine's the y. In this case, we want the sine, so we're picking sine 120, which is root 3 over 2. Okay. Only difference for 25 is that your angle's too small. So instead of minusing the 360 off, you're just going to add it back until you're in the positives. Okay. All right. And then this is the last section for first half. So take a look at your pictures or your equations. We're going to use the unit circle to solve these. Let's do 28. So I want to get theta by itself. I have a plus 17 over here. I'm going to minus that across. So 9 minus 17, that gives me -8. So I have 8 cosine 1/2 theta minus 5 equals -8. Next step, we're going to divide this 8 out of the front. Divide by 8, divide by 8. So I have the cosine of 1/2 theta minus 5 needs to equal -1. Then from here, to get rid of cosine, you're going to look on the circle for where that number happens. So for example, I'm going to find the angle where cosine, which is my x value, is -1. Notice I'm saying x value because it's cosine. If it were a sine question, I'd be looking at the y value. Okay, and then look up there at your circle, find where your x is a -1. Remember, your negative x's are going to be only on this side, and I see, boom, it's right there. Okay, so my answer is 180. So that crosses out the cosine. I have 1/2 theta minus 5 equals 180. And then to get rid of the 1/2, that's a divide by 2. So to get rid of a divide by 2, I'm going to multiply by 2. So 2.5 will cross out. I have theta minus 5 equals 180 times 2 is 360, and then add those extra 5 degrees over. So plus 5 plus 5, which means that your theta is going to be 365. Okay. Now notice that it says up here at the top that you want to give the complete solution. Remember, that's where usually you would add 360n to the back just to show all of the repetitions. But if there's a number in your equation that changes your period, then you need to take that into account. So hopefully you remember on this one, there is a number that changes the period. I see a 1/2 here in the middle. And so remember, that is going to change the period. Your normal period is 360 degrees. But if they put a divide by 2, then remember, you're really going to multiply by 2. Remember, it's always the opposite. So if they put a divide by 2, you really multiply by 2, which means that your new period is going to be 720. So your answer for this would be 365 plus 720. Okay, and remember that basically just shows, remember on the sine and cosine graphs, they're waves. They go on forever and ever and ever. So you're going to have answers repeating themselves every 720 degrees. I'm going to get a new answer. Okay. All right, we'll do 2 more left. Let's do number 30. Okay, 30, I have 4 cosine squared equals 1. I'm going to divide this 4 out of the way, so that I have cosine squared equals 1/4. And then to get rid of the squared, I'm going to take the square root on both sides. Square root of cosine squared is just a regular cosine in the middle. And then remember that when you square root a fraction, you're square rooting the top and the bottom separately. Okay, so in this case, the square root of 1 is a 1, the square root of 4 is a 2. Also, don't forget, something should go in the front. You should always give a plus minus whenever you take a square root. Okay. Then from there, it's a cosine. So you're going to find any angles. Find angles where the x value equals 1/2 or -1/2. Okay, why is it either one? Because of the plus minus. So then you're gonna look on your circle and then find each of those spots. So my positive a halves and my negative a halves happen. Let's look at the circle. I have a half here at 60 degrees, and then I have a half here at 300 degrees. I have negative a half here at 120, and then my other negative a half is here at 240. So I have 60, 120, 240, 300, these four right here. Okay, remember 4 is the most you'll ever get for an answer. So then it would be theta equals 60 plus 360n, 120 plus 360n, 240 plus 360n, and 300 plus 360n. Okay, you should never get more than 4 when you're solving. One other thing to point out is that, remember in the last example, you had this number that was changing the period. Okay, that's between the parentheses, versus on this one, I didn't have that. That's why I just left my 360n as a 360. Okay. All right, last one for the first half, number 31. Okay, first thing that I'm going to do is always add or subtract, because remember, when you're solving, you're doing PEMDAS backwards. So I'm going to get this -1 subtracted across to the other side. So I have my √2 in the front there. My sine 5 theta plus 100 equals -1. Then I'm going to divide the √2 across. So I have the sine of 5 theta plus 100 equals, and then when I look at this, remember, square roots are not allowed to stay on the bottom. So in order for me to fix that, I'm going to repeat the square root top and bottom so that I can fix it and find it on my circle. Remember, if it's not in simplified form, it's not going to show up on your circle. And so when you get to that step, you're going to be confused. So 1 times √2 is just -√2. And then √2 times √2 is just a regular 2. Okay. Then remember that normally I was finding the x value, but for this one, if it's a sine, I'm looking for y values of -√2/2. So let's peek up at the circle. We want y values to be -√2/2. So my y values are going to be negative in the bottom half of the circle. I have a -√2/2 here at 225. I have another -√2/2 here at 315. Okay, but remember, I'm looking at those y values because this is a sine question. Okay, so it's 225 and 315. So I keep the middle. 5 theta plus 100 equals 225, and then 5 theta plus 100 equals 315. Okay. Then from there, let's solve. We're going to divide this 5 out of the way. So I have theta plus 100 equals 225 divided by 5 gives me 45. And then I'm going to have to minus this 100 across. So 45 minus 100, that gives me -55. Now I'm going to put plus blank n, and then let's write the second one. Okay, so first thing I'm going to do is divide by 5. So I have theta plus 100 equals 315 divided by 5 gives me 63, and then minus that 100 across. So 63 minus 100 gives me -37 plus blank n. And then remember, the reason I can't put 360 is because if there's a number between your parentheses, that changes your period. So for example, remember on the last one, it was the 1/2 and we multiplied by 2. Well, then for this one, it's a times 5. So remember, that means we're actually going to divide by 5 because you're doing the opposite of what this number says. So if my period is usually 360, they tell me to times by 5 and it's in parentheses. Well, then I know I'm going to divide by 5. Then I know my period is really a 72. Okay, remember, you're doing the opposite of that number, so it'd be 72N and 72N. Okay, if you don't want to have to write the little theta twice, you could just put a comma in the middle, just like we did on the homework for that. Okay. All right, so this is a good place to stop for now. Go ahead and do all the questions that we skipped and then come back for part 2.